7.6 is the last chapter or section in chapter 7, and it deals with solving radical equations. Well, in order to solve these radical equations that you've already seen before, and you've probably used this property before, but you didn't know what it's called, we have to use the powers property of equality. And the reason we never introduced this property before is because it's really common sense. And it says that if A equals B, then A to the n equals B to the n. And that means that if you have two numbers that are the same or two variables that are the same, or basically you have this equation, if you raise both sides of the equation to the same power, then that equation it's still equal, it's still true. So we've been using this before when we square both sides or we take the square root of both sides, but we never really talked about it as a property. So to solve the following equations with radicals, we're going to have to use this property. So let's just jump right into it. So this first example is something you have seen before. We have the square root of x minus 6 equals 0. In order to solve this, we would add 6 to both sides, and we would get the square root of x equals 6. And then we would square both sides. So the reason we square both sides is because we want this radical in this square to cancel. So you can see how we go from problem to problem. Let me rewrite this. Let me write this as x to the 1/2 because the square root of x is x to the 1/2 equals 6. And you can see that as we square both sides, when we multiply these exponents, because that's what you do when you have a power to a power, you multiply exponents, they cancel. 1/2 times 2 is 1. So that's the reason all along why we've been squaring both sides. This becomes x, and this becomes 6 squared, which is 36. So x equals 36. Now we're going to keep the same process going. Here we have x to the 2/3 equals 16. So I have x to the 2/3 equals 16. And I'm going to have to raise both sides to some power in order to get this x by itself. Well, I want these exponents to cancel. I want them to be 1. So I want my final answer down here to be x. Well, the only way that's going to happen then when I multiply exponents is if I have 2/3 times something that gives me 1. The only way that's possible is I multiply by the reciprocal. So I'm going to raise both sides to the 3/2 power, because 2/3 times 3/2 gives me 1. So this becomes x. This becomes 16 to the 2/3 power. Or I'm sorry, 16 to the 3/2 power. And I can simplify this. So I'm going to rewrite this in radical notation. So it becomes the square root of 16 cubed. Well, the square root of 16 is 4. And 4 cubed is 81. I'm sorry, it's not 81. 4 cubed is 64. It's early. So we're going to continue this process on through the next couple of problems. And these are just a few examples. This video will be short. Here we have the square root of 2x minus 3 minus 6 equals 2. So the first thing I want to do is I want to get this quantity, everything under the square root by itself. So I'm going to rewrite this as square root of 2x minus 3 equals, and I add 6 to both sides to get 8. Now I'm going to square both sides. And this just cancels. The square root and the square, they cancel to 1. So I'm left with 2x minus 3 equals 8 squared, which is 64. And now if I add 3 to both sides, I get 2x equals 67. And now I want to divide by 2. So x equals 67 over 2. And keep it going. Again, I want to get this whole quantity by itself. This whole quantity here, I want to get this by itself. Each time when I'm solving these problems, I want to get these quantities by themselves. So the first thing I want to do is divide both sides by 3. So x plus 1 to the 4/3 power equals 48 divided by 3. Well, 48 divided by 3 is 16. And now I'm going to have to raise both sides to some power to get rid of this exponent. So I'm going to raise both sides to the reciprocal of 4/3, which is 3/4. So I'm raising both sides to the 3/4 power. And again, I raise it to the reciprocal because when I multiply these powers, they cancel to 1. So this is just x plus 1, because these powers cancel, equals 16 to the 4/3. So I'm going to rewrite this as the 4th root of 16 cubed. So x equals -1. I'm subtracting 1 from both sides. So x equals -1 plus, well, the 4th root of 16 is 2. 2 cubed is 8. So x equals 7. Again, something we've done before, but you haven't really solved these equations with rational exponents. So last two examples, a little bit different. We have two radicals, but the same process. We're going to raise both sides to some power and then simplify. So this first example, we have the square root of 6x minus 5 equals the square root of x plus 10. Because I have both of them as a square root, I'm going to go ahead and raise both of them, or both sides, because I have to do the same thing to both sides, to the second power, or square both sides. Okay, so now I have this square root of this squared, which is going to be 6x minus 5. Same thing here, x plus 10. Now I solve for x. I subtract x from both sides, and I add 5 to both sides. So 5x equals 15, x equals 3. And the last example is a little bit tricky. So just be careful here. This is where a lot of people make mistakes. Again, I have square roots on both sides. So I'm going to go ahead and square both sides. Now, when I square the first one, it is the square root of x plus 5 squared. So that just becomes x plus 5. But the difference here is this is 5 minus the square root of x squared. I cannot just distribute this square out. I do not get 25 minus x. That is not correct. Because this is a binomial, I have to FOIL. So I'm going to rewrite this so you can see. This becomes 5 minus the square root of x times 5 minus the square root of x. This is a binomial squared. So I have to follow my distributive property. So this is x plus 5 equals, multiply the first, multiply the outside, multiply the inside. Oh, I'm sorry, that should be minus 5 square root of x minus 5 square root of x. And this becomes plus the square root of x squared, which is just x. So I'm going to keep simplifying. This becomes x plus 5 equals 25 minus 10 square root of x plus x. And I still have a radical. So I'm going to try to get this radical by itself and then square both sides again. So let's see if we can do that. If I subtract 25 and I subtract x, so this becomes, the x's cancel. So this is minus 25 and minus x. The x's cancel. And then 5 minus 25 becomes negative 20 equals negative 10 square root of x. So now I'm going to divide both sides by negative 10 because I want to get this radical by itself. And this becomes 2 equals the square root of x. So when I square both sides, I get, let me write this in a different color. So I'm going to square both sides. and I get 4 equals x. Now, what you have to be careful about here is whenever you square both sides, you could introduce what's called an extraneous solution. So let me go down here and write this out. You could introduce what's called an extraneous solution. And I'm pretty sure I spelled that wrong. But like I said, it's early. I'm trying to get this video in, and I really don't care. So when you have an extraneous solution, you could possibly come up with more than one answer. And that's okay, or you have to check to see if your answer is correct. So in this case, we got x equals 4. So we're going to check and see if x equals 4 actually works. So I'm going to plug it in down here. So we have the square root of 4 plus 5 equals 5 minus the square root of 4. That was our original equation, and we just plugged in 4 as our x. So here we have 4 plus 5 is 9. Square root of 9 equals 5 minus 2. So this is 3, and this is 3. So this works. There will be times when you introduce, when you square both sides, you'll introduce an incorrect answer. This is not the case, but you always have to check when you square more than once to see if you have extraneous solutions. Solutions that look like they work after you've solved it, but actually do not work in the original equation. And we'll see more examples of that in class. All right, and the last part is a word problem. And this word problem deals with the Beaufort wind scale. And this is the wind scale they use to measure wind, believe it or not, or storms across the ocean, like hurricane speeds, typhoon speeds, stuff like that. And in this example, we have the equation B, which is the Beaufort number, equals 1.69 times the square root of S. S is the speed, the wind speed, plus 4.45, and then minus 3.49. And we're going to figure out the wind speed that corresponds to the Beaufort number B equals 7, which is like a tropical storm. So let's look at this example. The first thing we're going to do is just plug in for B equals 7. So 7 equals 1.69 times the square root of S plus, and I'm sorry my S's look like 5s. Not really much I can do about that. S plus 4.45 minus 3.49. Okay, so we're just solving for S. So the first thing we're going to do is add 3.49 to both sides. So this becomes 10.49 equals 1.69 times the square root of S plus 4.45. And we want to get this radical by itself. So we're going to divide both sides by 1.69. Divide both sides by 1.69. Now I'm going to go to my trusty calculator. Yep, that's the one I want. So we got 10.49 divided by 1.69. That gives me we'll go 3 decimal places, so 6.207. So 6.207 equals the square root of S plus 4.45. And now we have to square both sides. So we get, just going to use that same number, and we're going to square it. And that gives me 38 we'll do 5 to 8, so 38.528 equals S plus 4.45. And now we just subtract 4.45 from both sides. So minus 4.45, and we get 34.02. 34.02 is the wind speed.